Take a look at this equation. Many students think that when you have 2 plus x all squared, you can just distribute the exponent to get 4 plus x squared. But this is completely wrong. What's wrong with this approach? The truth is, exponents distribute over multiplication, not addition. This is where the power of a product rule comes in. In this video, you'll master the power of a product rule, understand how exponents really work, learn to simplify complex expressions, and discover the common mistakes that trip up so many students. By the end, you'll never make this mistake again, and you'll have a powerful tool for simplifying algebraic expressions. The power of a product rule is one of the most useful exponent rules in algebra. This rule tells us exactly what happens when we raise a product to a power. The rule states that when a product inside parentheses is raised to a power, we can distribute or share that exponent with each factor inside the parentheses. Think of this rule as sharing the exponent. The exponent n gets shared with both factors a and b, so each factor gets raised to the power n. Here's a crucial point to remember. This rule only works for multiplication. It does not work for addition or subtraction. Many students make the mistake of trying to distribute exponents over addition, but that's incorrect. Now that we understand what the power of a product rule is and when it applies, we're ready to explore why this rule works and see it in action. Now that we know the power of a product rule states that the quantity a times b raised to the n power equals a to the n times b to the n, let's understand why this rule actually works. The key to understanding this rule lies in what an exponent actually means. When we write the quantity a times b raised to the n power, we're saying we want to multiply a times b by itself n times. Let's work with a specific example to make this clearer. If n equals 3, then a times b cubed means we multiply a times b by itself exactly 3 times. Now here's where the magic happens. Because multiplication is both commutative and associative, we can rearrange these factors in any order we want without changing the result. Let's expand each factor to see all the individual variables. Each a times b becomes a times b, so we have a times b times a times b times a times b. Now we can use the commutative property of multiplication to group all the a's together and all the b's together. This gives us a times a times a times b times b times b. Perfect. Now we can see that a times a times a is simply a cubed and b times b times b is b cubed. This gives us a cube times b cubed. And there we have it. We've proven that a times b cubed equals a cubed times b cubed. This same logic works for any positive integer exponent n. The power of a product rule works because exponents represent repeated multiplication, and the commutative and associative properties of multiplication allow us to rearrange and group factors however we need. This fundamental understanding will help you apply the rule confidently in any situation. Now that we understand the power of a product rule, let's work through our first example to see how it applies in practice. Our problem is to simplify the expression 2x raised to the third power. Let me show you this expression clearly on screen. Notice that we have a product, 2 times x, all raised to the third power. According to the power of a product rule, we need to distribute this exponent of 3 to both factors inside the parentheses. Let's apply the power of a product rule step by step. First, I'll write out what this rule tells us to do. Now I need to calculate 2 to the third power. 2 cubed means 2 times 2 times 2. Now I can substitute this result back into our expression. 2 to the third power equals 8, so our expression becomes 8 times x to the third power. Finally, we can write this in its simplest form. 8 times x to the third power is written as 8x cubed. This works because we are applying the exponent to each factor in the product. The power of a product rule allows us to distribute the exponent of 3 to both the coefficient 2 and the variable x separately. Remember, this fundamental principle will help you simplify more complex expressions as we move forward. The key is to always distribute the exponent to every factor inside the parentheses. Now we're ready for our second example, which involves both a coefficient and a variable with an exponent. This will show you how the power of a product rule handles more complex expressions. Here's our problem. Simplify the expression 3y squared, all raised to the fourth power. Notice that we have a product inside the parentheses, the coefficient 3 multiplied by y squared. The entire product is raised to the fourth power. Step 1. We apply the power of a product rule. Remember, when we have a product raised to a power, we can distribute that exponent to each factor in the product. So 3y squared to the fourth power equals 3 to the fourth power times y squared to the fourth power. See how the exponent 4 has been distributed to both the coefficient 3 and the variable term y squared. Now we need to evaluate each part separately. Step 2. Calculate 3 to the fourth power. This means 3 multiplied by itself 4 times. 3 times 3 equals 9 times 3 times 3. 9 times 3 equals 27 times 3. And 27 times 3 equals 81. So 3 to the fourth power equals 81. Step 3. Now we need to simplify y squared to the fourth power. This requires the power of a power rule. When we have a power raised to another power, we multiply the exponents. So y squared to the fourth power equals y to the quantity 2 times 4. We multiply the exponents. 2 times 4. 2 times 4 equals 8, so we get y to the 8th power. Step 4. Now we combine our results to get the final simplified expression. We found that 3 to the fourth equals 81, and y squared to the fourth equals y to the 8th. Therefore, our final simplified expression is 81 y to the 8th power. This is our complete solution. Notice how we applied both the power of a product rule and the power of a power rule to simplify this expression. The key steps were: distribute the exponent to each factor, calculate the coefficient, apply the power of a power rule to the variable, and combine the results. This example shows how the power of a product rule works with both numerical coefficients and variables with exponents. You'll use this same process for more complex expressions. Now we're ready for our most challenging example. This problem will test your understanding of both the power of a product rule and negative exponents working together. Here's our expression: 4a to the negative 2b, all raised to the power of 2. Notice that we have a negative exponent inside the parentheses, which makes this more complex than our previous examples. The key challenge here is handling that negative exponent correctly. Remember, negative exponents don't make the result negative. They indicate reciprocals. Let's work through this step by step. First, let's apply the power of a product rule. We distribute the exponent of 2 to each factor inside the parentheses. We separate this into 3 parts: 4 squared times a to the negative 2 squared times b squared. Each factor gets the exponent of 2 applied to it. Now let's calculate each part separately. This will help us see exactly what's happening with each component. 4 squared equals 16. That's straightforward. For a to the negative 2 squared, we use the power of a power rule. We multiply the exponents. Negative 2 times 2 equals negative 4. So this becomes a to the negative 4. And b squared simply remains b squared. Combining our results, we get 16a to the negative 4b squared. But we're not done yet. We should simplify this negative exponent. Now comes the crucial step: converting the negative exponent to its proper form. Remember, a negative exponent means we take the reciprocal, so a to the negative 4 becomes 1 over a to the fourth power. So our final answer is 16b squared over a to the fourth power. This fraction form clearly shows how the negative exponent has been properly handled. Remember this key concept: negative exponents always mean we take the reciprocal. This is why a to the negative 4 becomes 1 over a to the fourth power in the denominator. Understanding this principle is crucial for working with more advanced algebraic expressions. This example demonstrates how the power of a product rule works even with negative exponents. The key is to apply the rule systematically and then properly convert any negative exponents to their reciprocal form. Now that we've worked through several examples, it's crucial to understand the most common mistakes students make with the power of a product rule. By recognizing these errors, you can avoid them and solve problems with confidence. The first and most common mistake is trying to distribute an exponent over addition or subtraction. Students often think that a plus b squared equals a squared plus b squared. This is completely incorrect. The correct expansion of a plus b squared requires using the distributive property or FOIL method, giving us a squared plus 2ab plus b squared. Remember, the power of a product rule only works with multiplication, never with addition or subtraction. The second common mistake is forgetting to apply the exponent to all factors within the parentheses. Here, a student might write 3xy squared equals 3x squared y squared, forgetting to square the coefficient 3. The correct approach is to apply the exponent to every single factor. 3xy squared equals 3 squared times y squared, which gives us 9x squared y squared. Never forget any factor, including coefficients and constants. The third mistake involves negative exponents. Students sometimes apply the negative exponent to only some factors, like writing 2x to the negative 3 equals 2 to the negative 3 times x cubed. This mixes up the signs incorrectly. The correct approach is to apply the negative 3 exponent to both factors, 2 to the negative 3 times x to the negative 3. Then we can simplify using the negative exponent rule to get 1 over 8x cubed. Here are 4 essential tips to help you avoid these common mistakes and master the power of a product rule. First, always double-check that you've applied the exponent to every single factor inside the parentheses. Don't skip coefficients, variables, or any other terms. Second, remember that the power of a product rule only works with multiplication. If you see addition or subtraction inside the parentheses, you'll need to use different methods like FOIL or the distributive property. Third, always follow the order of operations. Handle exponents before you multiply or divide, and be especially careful with negative exponents. Finally, practice with various examples to build both confidence and speed. The more you work with these problems, the more automatic the correct process becomes. Master these tips, and you'll be able to handle the power of a product rule with complete confidence in any situation. We've covered a lot of ground today with the power of a product rule. Before we wrap up, let me give you a clear summary of everything we've learned and how you can continue building your exponent skills. The most important thing to remember is the power of a product rule itself. When you have a product raised to an exponent, you can distribute that exponent to each factor inside the parentheses. This rule works because exponents represent repeated multiplication. When we raise a product to a power, we're multiplying that entire product by itself multiple times, which allows us to separate and distribute the exponent. We saw how this rule helps us simplify algebraic expressions efficiently. Whether you're dealing with simple numbers, variables, coefficients, or even negative exponents, the same principle applies every time. Now I want to hear from you. If this video helped clarify the power of a product rule, please give it a thumbs up. Your likes help other students find this content and let me know what's working well. I'd love to know what topics you'd like me to cover next. Drop a comment below with your questions or suggestions. Are you struggling with other exponent rules? Want to see more algebra topics? Your feedback guides what I create next. Your mathematical journey doesn't stop here. The power of a product rule is just one piece of the exponent puzzle. In our next video, we'll explore the quotient rule for exponents and how to handle division with powers. Remember, mastering mathematics is about building connections between concepts. Each rule you learn makes the next one easier to understand. Keep practicing, stay curious, and I'll see you in the next video where we'll continue strengthening your algebra foundation.